To achieve the cleanest power for a computer outlet, consider these strategies. Firstly, running a dedicated 20-amp circuit from the main panel directly to the computer outlet. This ensures the lowest possible impedance and minimal interference from other circuits. Secondly, you could install a subpanel dedicated to critical electronics, including the computer outlet. Run a dedicated 20-amp circuit from the main panel to the subpanel, and then from the subpanel to the computer outlet. This creates a more isolated power source for the computer. There are also tricks for making a clean computer circuit, one of which is using shielded or twisted pair cable. This reduces electromagnetic interference, or EMI. Be sure to install a surge protector or line conditioner to protect against voltage spikes and other power disturbances. Avoid running the circuit near other electrical devices. This minimizes interference from motors, fluorescent lights, and other sources of EMI. Also, consider using a dedicated ground rod, which provides a low impedance path for fault currents and reduces ground loops. Installing an isolated ground outlet can also help, as it creates a separate ground path for the computer, reducing noise and potential ground loops. Isolated ground outlets have an additional terminal that is isolated from the equipment ground, the green screw. This terminal is connected to a separate ground rod or isolated ground bar. There are benefits of isolated ground outlets, such as reducing ground loops and noise interference, and improving the performance of sensitive electronic equipment. However, it's important to note that isolated ground outlets require a properly installed and maintained isolated ground system. If not installed correctly, they can actually increase noise and ground loops. When running a dedicated circuit, it's best to use 12 American wire gauge or AWG copper wire for a 20-amp circuit operating at 110 volts. This is based on the National Electrical Code or NEC Table 310.15. This ensures sufficient current carrying capacity and minimizes voltage drop. Ensure all connections are tight and properly torqued to minimize resistance and potential for arcing. Consider using a high-quality receptacle specifically designed for computers and sensitive electronic equipment. These receptacles often have improved contact pressure and materials to ensure a solid connection. When installing a subpanel, choose a location that is close to the main panel to minimize the length of the feeder conductors. Use appropriately sized conductors for the feeder circuit based on the subpanel's ampacity and the requirements of NEC Table 310.15. Ensure that the subpanel is properly grounded and bonded according to NEC requirements. Use a separate grounding electrode conductor from the subpanel to a grounding electrode such as a ground rod or the building's grounding electrode system. When using shielded cable, ensure that the shield is properly grounded at one end only, typically at the panel end. This prevents ground loops from forming. Avoid coiling excess cable, as this can create inductive loops that can pick up EMI. If excess cable is necessary, arrange it in a figure 8 pattern to minimize inductance. A surge protector or line conditioner should be selected based on its surge current capacity and its ability to filter out noise. Look for a surge protector with a high joule rating, indicating its ability to absorb energy from voltage spikes. A line conditioner can provide additional filtering of noise and voltage regulation. When avoiding running the circuit near other electrical devices, maintain a physical separation of at least 3 feet between the computer circuit and other electrical circuits, especially those that power motors or fluorescent lights. Route the computer circuit through a dedicated conduit or cable tray to further isolate it from other circuits. A dedicated ground rod should be installed in accordance with NEC requirements, typically driven at least 8 feet into the ground. Use a copper ground rod that is at least 5/8 inch in diameter. Connect the ground rod to the electrical panel using a continuous length of copper wire of appropriate size, typically 6 AWG or larger, without any splices. When installing an isolated ground outlet, ensure that the isolated ground conductor is run directly back to the main panel or subpanel without any connections to the normal equipment grounding system. The isolated ground conductor should be green with a yellow stripe to distinguish it from the normal equipment grounding conductor. The isolated ground outlet should be clearly labeled as such to prevent accidental connection to the normal equipment grounding system. In addition to these measures, consider using an uninterruptible power supply or UPS to provide backup power in the event of a power outage. A UPS can also provide additional filtering of noise and voltage regulation. Select a UPS with sufficient capacity to power the computer and other critical equipment for the desired amount of time. Regularly test the UPS to ensure that it is functioning properly. Also consider the electrical code requirements. All electrical work should be performed in accordance with the National Electrical Code and local electrical codes. Obtain any necessary permits and inspections to ensure that the work is done safely and correctly. Hire a qualified electrician to perform the work if you are not comfortable working with electricity. Consider power quality monitoring. Use a power quality meter to monitor the voltage, current, and harmonics on the computer circuit. This can help identify any power quality problems that may be affecting the performance of the computer. Consider the use of harmonic filters. If the computer circuit is subject to high levels of harmonic distortion, consider installing harmonic filters to reduce the distortion. Harmonic filters can improve the power quality and reduce the risk of equipment damage. Consider the use of a balanced power system. In a balanced power system, the voltage between each phase and neutral is equal. This can reduce the amount of common mode noise on the computer circuit. Consider the use of a dedicated transformer. A dedicated transformer can provide isolation from the rest of the electrical system and reduce the amount of noise on the computer circuit. Select a transformer with a low noise rating and a high level of isolation. When selecting components, use high-quality components that are designed for use in sensitive electronic equipment. This includes receptacles, circuit breakers, and wiring. Use shielded connectors and patch cables to minimize EMI. Ensure proper grounding of all equipment. All equipment connected to the computer circuit should be properly grounded to prevent ground loops and reduce noise. Check the grounding connections regularly to ensure that they are tight and corrosion-free. Minimize the use of extension cords. Extension cords can increase the impedance of the circuit and introduce noise. If an extension cord is necessary, use a heavy-duty extension cord that is properly grounded. Avoid using power strips with surge protection. Power strips with surge protection can sometimes introduce noise into the circuit. If surge protection is needed, use a separate surge protector that is designed for use with sensitive electronic equipment. Keep the computer and other electronic equipment clean and dust-free. Dust can accumulate on electronic components and cause them to overheat, which can lead to noise and other problems. Clean the equipment regularly with a soft, dry cloth. Consider the ambient temperature and humidity. High temperatures and humidity can affect the performance of electronic equipment. Keep the computer and other electronic equipment in a cool, dry environment. Avoid running the computer circuit near sources of vibration. Vibration can cause electronic components to loosen and fail, which can lead to noise and other problems. Mount the computer and other electronic equipment on vibration damping pads. Consider the use of a power conditioner with harmonic filtering. A power conditioner with harmonic filtering can provide comprehensive power quality protection for sensitive electronic equipment. It can filter out noise, voltage spikes, and harmonic distortion. Regularly inspect the electrical system. Inspect the electrical system regularly for any signs of damage or wear. This includes checking the wiring, receptacles, circuit breakers, and grounding connections. Repair any problems immediately. Be aware of the symptoms of power quality problems. The symptoms of power quality problems can include flickering lights, unexplained equipment failures, and data errors. If you experience any of these symptoms, contact a qualified electrician to investigate the problem. Consider consulting with a power quality expert. A power quality expert can help you identify and solve power quality problems. They can also help you design and install a clean power system for your computer and other sensitive electronic equipment. When installing electrical equipment, be sure to follow the manufacturer's instructions carefully. Improper installation can void the warranty and create safety hazards. Use appropriate tools and equipment for the job. Using the wrong tools or equipment can damage the electrical system and create safety hazards. Be careful when working with electricity. Electricity can be dangerous. If you are not comfortable working with electricity, hire a qualified electrician to perform the work. Always turn off the power before working on any electrical equipment. Use a voltage tester to verify that the power is off before touching any wires. Wear appropriate safety gear such as safety glasses and rubber gloves. Be aware of the location of overhead power lines. Overhead power lines can be extremely dangerous. Stay away from them and never touch them with any objects. Call 811 before you dig. Before you dig, call 811 to have underground utilities marked. This will help you avoid damaging underground power lines and other utilities. Be prepared for emergencies. Have a plan in place for what to do in the event of an electrical emergency, such as a power outage or a fire. Know how to shut off the power to your home or building. Keep a fire extinguisher handy. By following these tips, you can create a clean power system for your computer and other sensitive electronic equipment. This will help improve the performance and reliability of your equipment and protect it from damage. And remember, always consult with a qualified electrician for any electrical work that you are not comfortable performing yourself. Ensure all electrical boxes are properly grounded and bonded. Use metal electrical boxes and metal conduit to provide a continuous ground path. Ensure that the grounding conductor is properly connected to the electrical box and to the grounding terminal on the receptacle. Avoid using plastic electrical boxes, as they do not provide a ground path. Use a dedicated neutral conductor for the computer circuit. Do not share the neutral conductor with other circuits, as this can cause noise and voltage drop. Use a neutral conductor that is the same size as the hot conductor. Use arc fault circuit interrupters or size. A size can help protect against electrical fires caused by arc faults. An arc fault is a dangerous electrical condition that can occur when electricity jumps between two conductors. A size can detect arc faults and shut off the power to the circuit, preventing a fire. Use ground fault circuit interrupters or GFCIs in wet locations. GFCIs can help protect against electrical shock. A ground fault is a dangerous electrical condition that can occur when electricity leaks to ground. GFCIs can detect ground faults and shut off the power to the circuit, preventing an electrical shock. Install lightning protection. Lightning protection can help protect your home and electronic equipment from lightning strikes. Lightning strikes can cause severe damage to electrical systems and electronic equipment. Lightning protection systems can provide a path for lightning to flow to ground, preventing damage. Consider using a whole house surge protector. A whole house surge protector can protect all of the electrical equipment in your home from voltage spikes. Voltage spikes can be caused by lightning strikes, power outages, and other electrical disturbances. Whole house surge protectors can divert voltage spikes to ground, preventing damage to your electrical equipment. Regularly test the surge protectors. Surge protectors can wear out over time and lose their effectiveness. Regularly test the surge protectors to ensure that they are still working properly. Replace surge protectors that have failed. Be careful when using power tools. Power tools can generate electrical noise that can interfere with electronic equipment. Use power tools with caution and avoid using them near sensitive electronic equipment. Consider using a line interactive UPS. A line interactive UPS can provide voltage regulation and surge protection, as well as backup power. A line interactive UPS monitors the incoming voltage and automatically adjusts the output voltage to maintain a stable level. This can help protect sensitive electronic equipment from voltage fluctuations and power outages. Consider using a double conversion UPS. A double conversion UPS provides the highest level of power protection. A double conversion UPS converts the incoming power to direct current or DC and then converts it back to alternating current or AC. This process isolates the output power from the incoming power, providing clean, stable power to the connected equipment. Consider using a power distribution unit or PDU. A PDU is a device that distributes power to multiple outlets. PDU can provide a variety of features, such as surge protection, voltage regulation, and remote monitoring. Consider using a K-rated transformer. A K-rated transformer is a transformer that is designed to handle nonlinear loads. Nonlinear loads, such as computers and electronic equipment, can generate harmonics, which can damage transformers. K-rated transformers are designed to withstand the effects of harmonics. Consider using a sine wave UPS. A sine wave UPS provides a pure sine wave output, which is the type of power that is required by most electronic equipment. Some UPS provide a modified sine wave output, which can cause problems with some electronic equipment. Consider using a zero transfer time UPS. A zero transfer time UPS switches to battery power instantly when there is a power outage. This prevents any interruption to the power supply to the connected equipment. Consider using a modular UPS. A modular UPS allows you to add or remove power modules as needed. This makes it easy to scale the UPS system to meet your changing power requirements. Consider using a hot swappable UPS. A hot swappable UPS allows you to replace a power module without interrupting the power supply to the connected equipment. This is important for critical applications where downtime is not acceptable. By implementing these strategies, one can establish a robust and clean power supply for sensitive computer equipment, mitigating potential disruptions and ensuring optimal performance. Remember, safety should always be the foremost concern when dealing with electrical systems.